step 3, we discussed that it is important to have a sample size which is sufficient for extracting segments from a certain number of segmentation variables. You may recall this picture. Here we have 2 segmentation variables only. Information about 6 consumers is insufficient to detect any segments. But if we add information about many more consumers, it becomes really obvious that we have 3 segments. This reminds us that we need a certain number of consumers for each segmentation variable. Based on our experiments, 100 consumers per segmentation variable is a good rule of thumb. Optimally, we collect enough data for the number of segmentation variables. But sometimes we find ourselves in the position that we cannot increase the sample. An alternative is to reduce the number of segmentation variables. How we can do this is the topic of this video. There are several reasons why we may want to select a subset of the segmentation variables only. The sample size may be too small for the original set. Segmentation variables may be redundant. This means that 2 or more variables contain the same or very similar information. And segmentation variables may be noisy. This means that variables contain information unrelated to market segments. As such, they make no contribution to segment extraction. We can take one of 2 possible approaches. We can try to identify the superfluous variables before extracting segments. We can inspect the distribution of each segmentation variable for the entire sample to identify variability across consumers. For example, if we study tourist activities and only 1% of tourists engage in horse riding. Horse riding is probably not an informative segmentation variable. Alternatively, we can use approaches which simultaneously extract segments and select variables. We will discuss 3 of those approaches, one of which, factor cluster analysis, we will advise against. The other 2 have been developed for binary variables because it's trickier to pre-select variables when they are binary. Factor cluster analysis is an approach you might come across frequently when you study applied market segmentation analysis. Here, the original segmentation variables are first analyzed using principal components analysis. Conceptually, what principal components analysis does is to turn data around in a way that the first few variables explain most of the variation in the data. Those first few, which are also referred to as factors, are then used in the second step to extract segments using cluster analysis. You can immediately see 2 problems with this approach. First of all, we only use a fraction of the information we have collected from consumers. If, for example, the variance explained by the principal components, our factors, used for cluster analysis is 60%, this means that we have effectively discarded 40% of the information consumers gave us before extracting segments. Secondly, segments are extracted in a transformed space. If we use the original variables, we understand what each one of them means. As soon as we transform the variables, it is not actually obvious anymore what they represent. This complicates the interpretation of results from factor cluster analysis. We ran a simulation study with artificial data with known properties and found that factor cluster analysis never outperformed cluster analysis on the raw data. One approach we can use to identify relevant variables while extracting segments when the segmentation variables are binary is biclustering. The basic idea of biclustering is to search through the entire consumer data and look for a group of consumers who all have values of 1 for a subset of segmentation variables. Then we take those consumers out of the dataset and look for the next group of consumers with the same property. The result of this iterative process returns a set of segments with consumers and segmentation variables attached to them. So if you look at this biclustering plot, each row represents 1 vacation activity or segmentation variable. Each column is 1 market segment. Looking at the activity museum, we can see from the dark blue sections left and right of the colored cells that segments 3 and 7 engage in this activity. The lighter colored section in the middle indicates that among all consumers, only few go to museums. Going to museums, therefore, is a relevant variable for this segmentation solution. The activities visiting spas, going on charter boat trips, and visiting theme parks are irrelevant for this segmentation solution. They are effectively omitted, although they were included in the analysis. Another approach for simultaneously extracting segments and selecting variables in the context of k-means clustering is so-called variable selection for clustering binary data. The basic idea here is the following. First, we find the best small subset of variables by trying all combinations of variables and selecting those with the best internal cluster index value. From here, we will try adding additional segmentation variables one by one. We know that each additional variable will make our internal cluster index worse. So what we do is we determine how much worse we let the index get for the benefit of being able to include another variable. Knowing the threshold, we can decide which of the remaining segmentation variables should be included next, if any. When no segmentation variables can be added without the internal cluster index deterioration being more than the threshold, the process stops. To run this method, we need to make 3 decisions in advance. How many market segments to extract, how many variables are included in the initial small subset, and what the level of the threshold is. As you can see, there are many ways to select segmentation variables, both before extracting segments and simultaneously with segment extraction. All these approaches are data-driven. The starting point is a dataset with suboptimal features like containing noisy variables. All of these selection methods are typically not necessary, however, if enough time and effort is put into data collection in step 3.